Let's talk about linear and angular speed. So, angular speed is the number of radians that the angle changes divided by the time elapsed. So, if you are spinning your keys, for instance, on a long lanyard, then you would be measuring your angular speed by the number of radians covered, which we can say theta, over an amount of time. So, theta divided by time. And theta, of course, would be in radians. And your time is in whatever time it happens to be that you're given. So it might be in seconds or in minutes or hours. So your label is going to be radians per, and then whatever that time is, radians per second, radians per minute, radians per hour. Your linear speed, on the other hand, is the linear distance traveled divided by the time elapsed. So if this is you, and here's your lanyard and here's your key, then your linear speed is basically the linear distance covered by your keys over a certain amount of time. So it's not the angle that's covered over time, but instead it's this distance. So it's really your arc length divided by your time. So we can think of that as arc length divided by time. Now we know arc length as S, so you might see it as S over T for linear speed. Or you can think of arc length, we found the formula for arc length is the radius times the theta, and theta is in radians. So we could rewrite this as R times theta divided by time. So if you notice, it is very close to angular speed being theta divided by time. So your linear speed is really taking theta divided by time and multiplying it by the radius. So if that's helpful to you, you can also, write down that linear speed is equal to your angular speed multiplied by your radius, right? Your angular speed is theta divided by time, so multiplying by the radius would get you your linear speed. So that might be helpful if you ever find your angular speed first, you can just multiply by the radius in order to get your linear speed. Now, when it comes to the labels for your linear speed, the numerator is your arc length. So this is a distance, a linear distance. So it might be inches or feet or meters or miles. And then your denominator is your time. So it might be seconds or minutes or hours. So we're looking for something like that for your label. So let's look at an example. If you rotate a yo-yo on a 3-foot string at a rate of 15 revolutions every 10 seconds, what are the angular and linear speeds of the yo-yo? So let's start with angular speed. As a reminder, angular speed equals theta divided by time. So the number of radians that are covered when you are rotating that yo-yo. So think about one rotation of the yo-yo. If we look at this kind of from above, when that yo-yo goes around one full time, the number of radians covered is 2 pi. So that's just one revolution, but you're spinning it 15 times. So if we take 15 and multiply it by 2 pi, then we get 30 pi radians that are covered in all 15 of those revolutions. So your angle measurement, your theta, is going to be 30 pi radians, divided by the time that it takes to do that, which is 10 seconds. So we want to reduce, and we're going to keep our answer as an exact answer. So I'm going to reduce 30 divided by 10 is 3. So we would have 3 pi radians per second. So hopefully you can picture what that looks like. We know what 1 radian looks like. We know what 1 pi radian looks like. So 3 pi, think about what that is. Here's 1, here's 2, 3 pi. That basically means 1.5 revolutions every second. So 3 pi, 1.5 revolutions per second. So you can envision that speed, that angular speed, versus our linear speed. So for linear speed, we know that this is r times theta divided by time. So you can either start from scratch and plug in everything you know, Or remember, that's the same thing as taking your angular speed, which was theta divided by time, and multiplying it by your radius. So it's completely up to you. But one thing that we could do, we could say, well, our radius is 3 feet because it's a 3-foot string, times your theta. We already said that that's going to be 30 pi because it's 15 revolutions, 2 pi radians per revolution. So 30 pi divided by 10. Keep in mind, this is going to be the same thing as, again, just taking radius times your angular speed, 3 pi, because 30 pi over 10 pi is 3 pi. So what we end up getting here is 9 pi. Now I want you to think about what your label would be. If we're talking about arc length, then that means what is the distance, the linear distance covered by that yo-yo? Since our radius is given in feet, that means our linear distance is going to be in feet, and then our time was in seconds. Now, this is our exact answer for linear speed, but that doesn't necessarily help me too much. If I say that if there's a sign on the highway that says your speed can be 9 pi miles per hour, you might look at that sign and think, what on earth does that mean? So having pi as part of our answer in linear speed doesn't make as much sense to us as when we're talking about angular speed. So I would actually advise you to find the approximate speed here by typing that in your calculator. So 9 times pi is about 28.3, and then our label feet per second. So this probably means a little bit more to us. I can picture the yo-yo covering 28.3 feet in every second. We'll do one more. A winch. So this is a winch of radius 2 feet. So this is 2 feet right here. It's used to lift heavy loads. If the winch makes 8 revolutions every 15 seconds, find the speed at which the load is rising. So in this case, if we're looking for the speed at which the load is rising, that's going to be a linear distance over time. So we're actually looking for a linear speed here. So sometimes it's going to be up to you to determine if it's angular or linear speed that they're looking for. So we know that this is arc length divided by time. And keep in mind that the arc length, one full revolution around the circle, so the circumference of the circle, is the distance that's going to be covered by this heavy load each revolution, right? So this circumference is how much the load will rise every single time that winch makes one full turn. So we have the radius times theta. Your radius is in 2 feet. And theta, well, it makes 8 revolutions. So remember, for a single revolution, that's going to be 2 pi. So if there's 8 revolutions, multiply that by 8, and that would be 16 pi for theta. Divided by our time, it's every 15 seconds. So think about how we would simplify this. 2 times 16, that would be 32 pi over 15, which we could then label our units. Our arc length would be in feet, and our time would be in seconds. So we could say 32 pi feet per 15 seconds. This would be an exact answer because it doesn't simplify any further. But again, a linear speed, it usually makes more sense if we talk about an approximation. So if we were to type that in our calculator, we would get 6.7 feet per second.